Hello, welcome. How's it going? You guys salty, tired, shackly? I'd talk about SHACL for a minute. And I'll point out some other aspects of SHACL. I won't spend too much time on this because instead I'd like to spend the majority of the time on your projects. So we can do some work in here on the SHACL project. So I think that'd be a good use of our time. But I do want to highlight some aspects of SHACL, that I discussed, some of which I discussed last time. And in passing, kind of a quick overview. I want to give you a little bit more depth on some of those, and I want to highlight some other aspects that I didn't highlight last time. But as I said, this will not take up so much time because I'd rather do some hands-on work than the projects specifically. So workflow, the SHACL sort of workflow. Check this out. In the workflow, you have a graph, RDF. Here's an example. There's Alec, we know Alec. There's Fede, we know Fede. There's Carter, we know Carter. We all hate Carter. I'm just kidding. But this is just a graph like you've got. And you've got something, it has a name, it has an email associated with it. Here's the shapes that you might expect. If you're thinking about this visually, you've got some nodes and edges in the graph. Look, there's Alec. Look, there's a property relating his name to his name. And similarly, you have an email property related to his email. Cool, easy peasy. Here's a shape graph, a constraint graph. Observe, you have like a person shape. It's a type of node. It has target nodes. They should look familiar, Alec and Fede and Carter. And it's saying that these things have to have a certain type. They're kind of thing. They're IRIs. And then they have properties associated with them, names and emails. And if you look at that has name, right? That property has name. You see there's more information down here constraining the shape. Has name, has certain constraints on it. Namely, you have to use this object property to characterize it, EX name. And it has to have, you have to have exactly one of those. That's a string. Here's a graph. Here's the graph that you're looking for up at the top. Here, graphs at the bottom. You see the person shape node over here at the top corresponding to these specified named nodes in the graph, in the RDF. So far, so good. You also have these properties that are connecting in the graph or in the shape graph that are supposed to correspond to stuff you see in the RDF graph right there. Look at that beautiful cascade of arrows. So far, so good. Minimum and maximum one on the has name, and they have to be strings, right? Which is good. That's exactly what you see here in the RDF. Now you feed this. So you feed this into the processor. It could be whatever. It could be some Java or Apache. It could be RDF lib or whatever, PyShackle, whatever you need, whatever you want, some processor, and it should output. If you were to feed it these two graphs, it'll spit out a validation report that says your RDF conforms to the SHACL constraints. So that is in general a high level overview of how this stuff works. The SHACL, you put the constraints and they're supposed to reflect something in the graph, or at least constrain how the RDF graph is supposed to look. You can think about it visually as what I described, like those little nodes and edges that there might be many of them, but you have a shape that's supposed to correspond to them. And if there's deviation, you're not going to get conforms true, you'll get conforms false. I'll show you an example of that in a second. But if you've got them lined up correctly, the shapes lined up correctly, you're going to get true. Check this out. Another example, shape graph, RDF graph. The shape at the top is saying this. We're looking for a person node in the shape file. Things hanging off of this are going to be associated with an RDF EX email. So in the RDF graph, you're going to have EX email, and it will be associated in this path to a value that is an IRI. So as you see here, whoever, I don't know who this person is, but whatever this person is, she has the wrong email. Josh, I don't know, Josh, do we know a Josh in here? We know maybe there's a Josh in here, I'm not sure, but you see these individuals, Alana and Josh, are representing it. Look at that. Look at those beautiful, beautiful RDF people. You have a shape and you have the thing. Okay, now this is one perspective, right? We're looking at the graph structures. This visualization doesn't actually reflect all the details that we need to evaluate. We do know this much. These lines better be EX email. Why? You see it up there. Property, path, EX email. That's what the shape graph says. They better be EX email. These nodes better be IRS, right? As it says, the value of EX email better be an IRI. Let me ask you real quick. Are these IRS? Are both of them?
One is a string.
Mm-hmm. Josh, unfortunately, used a string. Need those brackets, baby. Does that make sense? So you,
I didn't even know. Okay.
yeah. You feed this into a processor, and what you'll get is a false conformance. Now, of course, there'll be more information. You've seen like their message outputs. You'd be like, not only is this not conformant, but it sucks for this reason. Like it'll point you here, point you to this. It'll point you in the node, like the part of the shape graph that generated the violation. It'll tell you exactly in the RDF graph what went wrong, right?
John, can you flip it too? Can you use the SHACL shape so that you can feed an LLM so that it builds it in Python the correct way?
Oh,
Or
yeah.
it looks for the correct things that add to it, or it notices that this isn't right, and so it has to put, say, mail to : in front of josh@mail.org?
That's right. And if you are clever, you will.
Yeah.
That'll be a great way to fix this. And you should leverage tools in your toolkit to do such things. Or you should have QCs, or you should have SHACL as part of your quality control built into some like pipeline that does this sort of stuff for you. Like ideally that will be the setup so that you don't actually have to look at this stuff. But ultimately things are going to break down that won't be automated. Like you can't fix an automation like that. So still good to understand how these conformance reports and validation reports work and how you can generate problems and how you can fix them. So some other things to point out. Again, I mentioned some of this last time. I'll mention more now. So these values over here, these are values in the SHACL. Like you can target specific nodes. You saw some of that. I was pointing to in that first example, I was pointing to nodes with names. Alec, Carter, right? You can also instead point to classes of things. Person. Anything that's a person has to have these constraints. You can also talk about relations and specifically the subjects or the objects of the relation, of the relata. You can talk about those relata, like the first one or the second one. So if I'm looking at, again, the target node, it lets you identify specific nodes to be validated against a shape. In this case, as I said, Alec, Fede, Carter, and these are the things you see in the graph. It doesn't have to be just the specific names, though. You might want to be more general. You could talk about classes like person. It will still apply, right? Now I don't need to name Alec or Fede or Carter. I can just say, look, they are of a type person. Focus on that. It's a nice way to summarize, so you don't have to type out names. Also, the target subjects of. So remember, this is a way you can pick out the relata of relations. So this one's the target subject. So it's the first part of the relation. It's the first thing that's related. And in this case, you're talking about that's relationship through teaches. So the first thing, the X and Y, X teaches Y. And then you're saying, here's some constraints on things that fall into that X value, the domain of teaches. They have to have relationship to a name, exactly one. It has a value that's a string. Observe the RDF data. Which ones pass? Which ones fail?
Does SHACL just constrain everything? So it's like closed word assumption or open word assumption? So
We'll get to that in a second. Remember, first relata of the object property is the thing being targeted here. In this case, the first relata should bear name to exactly one string. That one's fine. That one's not. That one is ignored. This ignores it. Know the difference, right? There's CCO name.
Yeah, but that still doesn't tell me that there is a part in the graph where it has also EX name, right?
That's right. But this says it has to have EX name.
Yeah, but maybe another part of the graph. Or
Not
is
for
this,
not for Finn.
is this box our whole
This is
graph?
your whole graph. Yeah. So this says that says you have to have at least one and at most one.
Mhm.
And so it doesn't have EX name.
So why is the bottom one ignored though?
So this one's
Wouldn't it
ignored.
be wrong too?
Yeah. I mean, this one is ignored because I think the issue is that it is not related through teaches.
Yeah.
So that constraint up there is saying, here's constraints on the relata. The X, the thing that it stands in the X of the domain of teachers. Right? It's namely they have to have like an EX name, exactly one, and it has to have a string. And so in here we have Austin, and he does have a CCO name, which is not an EX name, but he's also not in the domain of teachers. He's not a teacher. So it just kind of ignores this. Does that make sense?
Yeah.
Awesome. All right. There's some logic built in here too. So it's useful to know. You can manipulate the logic. You can build some pretty sophisticated shape queries. I showed you some of that earlier, or like last time when we talked about how you capture conditionals. It was just the traditional way of like translating an if-then statement into a negation and disjuncts. So if P then Q translates straightforward to not P or Q. And you can model that because we have logical operators in SHACL in the SHACL graph for like or and not. Let me talk a little bit more about those operators though. So conjunction, observe, you have person node, and you have and. Now I'm going to claim, this is true, that these two graphs, these two shape graphs are equal. One of them has and the other one just lines up two constraints, essentially. If something embraces in the scope of like a logical operator, in this case, SH and, you read them as conjoined, like they're separated, these two sets of brackets, or these four sets of brackets in the top, four sets on the bottom, those are the conjuncts. First conjunct, second conjunct. Oh wait, those errors should have been pointed differently. You see, first conjunct, second conjunct. So this and that. If you look over here, there's no conjunction. But the default interpretation for new lines surrounded by braces is just conjunction. So you read these, they're line by line. They're assumed the default interpretation is that it's this and that. So this is why they're equal. Now there are other scenarios in which you'd use and, where you're not lining things up like this, more complicated expressions. But like, again, just important to highlight. Conjunction does exactly what you think it does in logic. It takes one thing, it takes another thing, it puts them together. But there is a default interpretation of new lines as being, within braces, as being conjoined. That's right. More interestingly is disjunction. SH or. You see, we do have those two lined up, like these two sets of braces. But to avoid that default interpretation of conjunction, we'd add the disjunction or. So now the default interpretation has been overridden. We wouldn't read these two sets of braces as conjoined. We'd read them as disjoint. If you're looking over here, well, again, I guess these are true as long as one of the disjuncts is true. That's normal. And you'll see in the top, Jisoo. I think we know Jisoo. I think we're proud of Jisoo. We're happy Jisoo's here. Jisoo satisfies this top one. J satisfies the bottom one. But silly Sean, I put this in there specifically for you, Jisoo. And he's not here to defend himself. Uh, so this shape says, things, persons in this case, they have to have, or at least the things in this graph, they have to have either EX name or an RDFS label. One or the other. They could have both, but one or the other at least. And Sean, for all his faults, has neither. And for that reason, he fails. Negation, which works just as we think, right? It just means no. That's it. There's nothing more to it. In combination with these other logical operators, though, you can get some quite powerful stuff. As I said, with if then, if you're trying to capture that, you can use this at the head of a complicated set of braces and with a disjunct involved, and that's essentially an if then statement. In this case, just to show you, personal node shape, not a shape that has this faux name, at least. So whatever's in the brackets is not allowed. That's basically what it means. Mike screwed up. You can have an EX name. You can have an RDFS label. Literally, you had one job, Mike. No faux. Which is in general a good principle for what it's worth. Stay away from faux. All right. How about this one? Putting constraints on the lengths of strings. This is pretty useful. The string can't be so long, can't be so short. This is part of the power of like getting into the value space, like the regular expressions, like the actual strings. Like you can put constraints on the literal strings, the literals, as it were. So this is saying, something related to the path name. The value has to be at least 4 characters long, no more than 10. Strains the links to the valid strings. David and Lewis. That's fine. I didn't do that on purpose, incidentally. I was thinking of David Brown and Lewis Powell. And then but I ended up putting David Lewis there. It's a famous philosopher, one of my idols. Of course, these are not strings. So this fails. Or it's ignored. I think in this case, it actually does fail because it says a minimum length, and that means a minimum length of a string, and you can't count IRIs like that because you're not counting strings. So I think this, in fact, does fail. One of these, incidentally, is blank node. The other was like an IRI, like a more traditional IRI that you see, like name. Neither is a string, then. Now we get into what Fede was talking about, the closed and open world. You can impose closed world assumptions in the shape graph. So as you recall, in OWL, we operate with the open world assumption. That's the default. Just because you haven't said something doesn't mean it's false. SHACL operates in a similar manner. You can impose closed world assumptions on it, which is very useful. Sometimes, as I said, when I was talking last time, some of the motivation for having closed worlds, sometimes it's reasonable. If you can really be sure that there is nothing else that falls under this, or you shouldn't allow for anything else that falls under this predicate or something. It's a lot easier to say world's closed than it is to say any new thing you get at any more given time, I'm going to explicitly say no to that, no to that, no to that. It's easier just to have a rule. And this is a way to impose that rule. So here you have you use SH closed and you say it's true. Enforcing the closed world assumption. You can also put exceptions in. But before we get there, so this says in the closure, the graph must only have values for properties that appear here, like first name, surname. And so no others, except the exceptions. So this is like an optional clause. You're not putting any additional constraints. You're not saying anything more about it. You're just saying if it has an RDF type, it's fine. And in this case, Ella has an RDF type, but she also has a first name and a surname. Of course, one of these fails. Which one fails? Surprise, it's Papa. have an RDFS label. That's not one of the exceptions. Closed world assumption. That's what it means, right? Remember? Instead of taking that line that we have to do in the open world, where we say, if you want to say you can only use first name and surname, you have to say, well, you can't use RDFS label, you can't do or RDFS type, you can't do this, you can't do that. You have to name them. Instead of doing that, we just impose the closed world and say, maybe there's some exceptions, but really you should only have these two. And you know, I failed. RDFS label. I'll send it to my mom. Just a summary of some of the various tools you can use, the types. You can constrain cardinalities, min count, max count, types of values you want to target. The values themselves, like nodes or things in nodes or things with certain values, ranges of values. I'll let you look up the minimum, exclusive, inclusive, but it's exactly like what it describes. You can have like boundaries or bounds, like numerical bounds for ranges of values, languages, logic, closed shapes. Default is open, but you can impose the closed world assumption. You can also employ equals, disjoint, less than, or equal to. These apply to properties and paths. And then qualified shapes are above your pay grade right now, but they're interesting nonetheless. But I won't cover them today. What I'll instead do, that's not today. What I will do instead is turn it over to your projects. So how's it going? Dustin Slap. Who the project leads? Joss and Giacomo.
That is with me too.
Okay, fill me
That is my
in.
name in.
Fill me in. How's it going?
John,
Yeah.
for our project, like I asked in the last class, I did send you an email.
Okay.
The documentation, it doesn't exist. I did go to
Well,
the way back.
Huh.
It's a really weird documentation, and I'm trying to find other resources to be able to do it. But if I have someone that's done this before, then they can point me in the right direction.
I'll put you
All
in
right.
touch with Sydney because she's done it before.
Okay.
I sent OB on a wild goose chase through the Internet Archive to find old documentation. But cool.
What?
For Australia.
Yeah.
The GitHub repo used to have documentation on it. I might find it. Sydney has used it before. She knows. I'll put you in touch with Sydney. But project leads, what's up?
So today's gonna be the first day that we're a little bit lacking in this area, but for the most part, everything else is pretty good. We haven't formally met yet all together, but we've been having some communication. We've been working on some things. I know that some people have put together some stuff for automating. So we should be talking about that today, getting a clear picture of what we want, and then hopefully this next week will be a series of meetings where we can put it all together, and then saving enough time for the validation and the reports. So I think today is a good time for everybody to show it more on together.
Okay. Better, you want to add
Yeah,
anything?
so, yeah, we discussed actually smaller chunks, more and everybody together. It was not easy to find time for everybody.
Imagine.
Happy that we can do it now, with John, there's probably McLaren is there, and Jay. We had some competency with some expertise that we can develop.
Mm-hmm.
And, we have a couple of people that can code, so we can
Yeah.
use that, something in Python. We have at
Good.
least one subscription to ChatGPT to do the NPL that is needed. And we also reach success in distilling confidence in every part.
Instilling confidence.
Instilling.
That's
You
weird.
said.
I would say reaching success by instilling.
Instilling confidence. That's
Yeah.
right.
That's it.
Instilling confidence.
Motivation is the key.
Motivation is important.
Now,
So Tim and I were moved groups after last week's class, and so we had already set up like a pathway forward with Giacomo. And
Nice.
then all of a sudden we were in a different SHACL group, but I did share my YAML file. I shared my YAML file with Giacomo and our group.
Uh-huh.
If anybody else is using NOS or uses ChatGPT and wants the YAML file, just ask me.
Yeah.
I
That's good.
really want to know how well it works with you guys because
Mhm.
it does some things relatively well.
Good.
And hopefully you have the same success.
Good. Yeah, I too would encourage Nas using Nas AI.
There's also, I think if you reach out to Jeremy,
Yeah.
there's a UB environment that he
Mm-hmm.
for your students. He needs to put me in that, but and then the cool thing is when we're in there, we can share we can share AI agents with each other.
Oh, good.
Or
Yeah.
if somebody
In fact,
builds
you should
one
all
in
just do
there,
that.
everybody else can use it.
Mm,
So
good.
I have one that's like an ontology editor that I've shared the YAML of.
Mhm.
Uh,
What's it called?
well, I named it Barry. I think
Ah,
yeah. Originally I named it Barry. So
love it. Giacomo, you want to add anything?
So I think right now we're about to start doing the LLM side of this of the
Mhm,
project
good.
because we're kind of fed up with Astrea and with SHACL and with all that stuff.
Okay.
So unless Obi, I wasn't thinking about Internet Archive, but that's actually a very good idea. Unless Obi is magically able to.
It was a goose chase though.
Yeah,
Looks like you didn't find
if
anything.
that works, that's
Uh-huh.
great. If not, we're probably moving to the LLM side of things. I was actually planning to use this as an opportunity to um make tests.
Mhm.
So this is art, this is logic, and it's code.
Yep.
And they know LLMs know a little bit of code, not a lot of logic.
That's right.
So it's a nice test to see how NAS works against ChatGPT and against ChatGPT plus YAML.
Mm-hmm. Mm-hmm.
So I was planning to divide groups to do that and
Very good.
evaluate this.
I like it.
to be honest, they're both good at different things, right? So one of the things that NOS can't do, because I don't think they've built it into the code base, is it can't look at an external source, right? It only uses like I think it uses a limited version of ChatGPT. So a good example of that is I can tell ChatGPT to go to the CCO GitHub
Mm-hmm.
and research something, and it'll go through every file that's on the GitHub and it'll come back to me, right? So if I'm looking for something, say I even wanted to look up and see if there's been discussions about information content entities in the tracker, right?
Mm-hmm.
ChatGPT can go do that. NOS can't do that, and it'll tell you, "I apologize, I can't look at external sources."
Mm-hmm.
So that's a huge limiting factor right now with the NOS platform, and I'm sure that's just something that they haven't built into it because I'm sure that takes a lot of work and code base, but
Yep.
that's a limiter right now.
I'm
Mm-hmm.
not even sure that NAS is using GPT. Whether
I think it's one of the
Well,
options.
so there's like 9 options,
Yeah,
right?
Yeah,
Actually,
you can select which one you want to pull in Anthropic or whatever. It doesn't matter.
Yeah.
Yeah.
And it's free for
Yeah.
us. Right?
Well,
So
when he gives you credits, I mean, he just bumped me up to, I don't know, like
Which is nice.
1,700 credits or something.
That's nice.
But another thing is when you pick your model,
Mm-hmm.
You can pick between, so like most of the ones I use is like OpenAI GPT-4o, but
Mhm.
there's another one that he told me about, and I think it's by Mistral. And he said, yeah, I've been told this works better with ontologies, right? And I tried it for like 2 days and I didn't really like it. So I went back to GPT-4o. But there's about 10 different models. So maybe certain functions work better in different GPT models. And that would be an interesting kind of
Absolutely.
something to explore if you have time, you know.
Absolutely. And presumably it'll come out, some of this will come out as you're exploring using NAS. It's one of the reasons I want you to reuse. I encourage you to use NAS. And I encourage you to use different models, different strategies. Some of these things are going to be more useful than others. They'll have better outputs, but you at this stage in the development game of these things, you should use something of a shotgun approach.
Yeah.
Not perfect, but altogether they're better than not. So with that, okay, thank you for the overview of the projects so far.